A ball swings freely back and forth in an arc from point 1 to point 4, as shown. Point 2 down here is the lowest point in the path. And essentially in this question, we want to find the speed of the ball at point 2, given the height at point 1 and 4. So to do this, we can use conservation of energy. We're going to be comparing the initial energy in the system, or the energy before we release it from its highest point, to the final energy of the system, or the energy when it's released and it's at the bottom of its trajectory. So initially, the energy is just potential energy. It's at some height, specifically at point 1, and it's not moving. And the final energy, or after it's released, right at the bottom of the trajectory by point 2, the ball does not have potential energy anymore, but it has kinetic energy, EK. So we want to find the speed of the ball at point 2. All right, so let's substitute in the equations for potential and kinetic energy. We have mgh for potential and a half mv squared for kinetic. Our masses are going to cancel, and we can just solve for the velocity. Multiply everything by 2 and then take the square root. So we'll have 2gh all square rooted. If we plug in our values, we'll have 2 times 9.8 meters per second squared multiplied by the height at point 1, which is 1 meter, and that's all inside a square root. If we multiply all those guys together, we'll find that the velocity at point 2 is 4.5 meters per second.